Good evening, everyone. Welcome to Basic Linux for Life Sciences. So I'm Shadrach Eze, and we'll go through these objectives. So these are learning outcomes, how to host Linux on Windows, understanding command line interface, the file structure, and everything. So we'll run through this in less than 30 minutes. Yeah, so join me. So how do you host the command line operating system, maybe on your Windows? Most of the times you can install it side by side with your Windows, and then during the boot you can decide which operating system you want to launch. That is easy because it is easy and it is nice because both operating systems are separated. When you are in Windows, you don't have access to Linux and then all of that. So, but that also takes a whole lot of space too, and also involves a whole lot of complexity. So you can also use a VirtualBox, which is a virtual environment where you can host your Linux. I've also used VirtualBox and it's really nice. The downside is that VirtualBox on its own is a software which is heavy. You need to install it before you use it. So, and then for Windows users, you can also use WSL. That is what I use currently. It is very light and support almost all the commands available for normal Linux systems. And then it is easy to install using WSL install from your Windows PowerShell. For Mac OS users, you already have a Linux interface, so you just need to launch it and then use it. Okay, so what does command line interface look like? So here is a comparison of the graphical user interface and then the command line interface, as you can see. So the graphical user interface, everything is click and play. But in the command line interface, you need to type your commands and then execute them. This is the general file structure of the command line interface. So we have the root, that is where everything begins. It's structured like a tree, where everything starts from the roots, the trunk, the branches, the leaves. So from the roots, you can have your home, you can have bin, etc., some other directories where system level files are stored. And then, but at the home, that's where you have direct access to store your own permanent folders and everything. So let's talk about directory. What is a directory? So a directory is just the way files are organized in any system. And the root directory is the most lowest layer. That is where, think of it as the foundation. That is where everything is built on the Ubuntu system or the Linux system. Now, we also have the home directory. The home directory is represented here as home. Usually when you log into Linux, the home directory is where you land, right? Yeah, but it can also be configured, but let's just take it as the landing page as we're going to see later on. Working directory is where you are currently. So where you move around, enter files, delete files, change directory, where you are currently is the current directory. And these signs are what represent them. Tilde sign, the slash sign, the full dot sign. These are the signs that represent current working directory, home directory, whatever. So let's talk about a path. A path is a series of characters that can locate your file in the whole file structure. So think of a path as the steps you need to take to get to where your file is. So let's assume you are here. Let's assume you are in the root directory. How do you get to document? So you can move from root to home to gdo, then to document. This is a path. Now, there are two classes of paths, the absolute path and the relative path. They're just very simple. So the absolute path always starts from the root. So if I'm talking about root, home, gdo, and document, I'm talking about the absolute part of the document file. But the relative part doesn't start from the root. It starts from wherever you are. So let's assume I am in Jolo. How do I locate document? So from Jolo, I will move back to home, then find gdo, then find document. This is a relative path. Now, relative path changes because once you move from one place to another to locate the same file again, your path has changed. But absolute path never changes because it always starts from the foundation, from the roots. So let's turn to the basic commands of available in Linux. So the print working directory shows you the path of where you are currently. The cd change directory, ls list the content. You can add l, you can add e, you can add whatever you want to add. You can even sort your files. Make directory, create a new directory. Remove file. So if you put -r flag, you are forcing a remove. So you can use -r to remove folders because folders cannot easily be removed by rm alone. Copy command cp move. Move command can also be used to rename files. Divide command. So if you want to create files, you first of all open them up, put in the content, save them out. That's actually how to create file. Although you can still create without opening them using some other command like touch, but usually vim, nano, gedit, vi, and create your files. That is a way to list the contents of a file. So cat, ls, whatever. Word count, you want to see the contents, the actual contents of a file. I mean, in terms of number, how many words are there, how many letters are there, how many characters. Grep command, these are high-level command you use to search files. Gmod to change permissions, and on and on and on. So let's talk about copy command. So if you want to copy a file from one destination to another, call the cp command. You select the path of where the file is, then you end it with the file, then you select the path where the file is going. So it's like two-level thing. Where is the file currently? Where is it going? Simple. To move from one location to another, it's still the same thing. Move command. Where is the file? Where is it going? Remember that when you move a file, it is no longer available in the original directory, in the original location. Okay? So we can use this idea to rename a file, since when you move a file, it is no longer available in the original directory. If we move a file from the current directory back to the current directory using another name, we eventually rename it because we remove it and bring it back as another name. So that's how you rename file. So path from file, then path to new file name. So in the same place, you move it, bring it back at the same time. Okay, so there are other commands like the greater than sign command. These are commands you use to, they are called piping command in the sense that you can use them to redirect your output. So you can decide to list the content of a file and send it to another file. List the content of a file and save it to another file. You can use the greater than sign, the double, the greater than sign. So the double file, we create a new file or override an existing file. So these are just the difference. So you can list the content of smypdb and send it to maga.txt. So that is very simple. You can also list it and send it to maga.txt if maga.txt does not exist, or even if it exists, it will override whatever is already there. So that's just it. So be careful with the double sign. So still talking about piping commands. This sign is a piping sign. It's mostly used to tell the system to use the output of the previous command as the input of the next command. So if I am running a command and it outputs, let's say 7 as an integer, but I want that 7 to be the input for the next command. Do you understand? Then I will use the pipe function. This pipe command, it's just a single line, and then it will send it out. Then you can also use semicolon. You can use double ampersand to combine commands. So the basic difference is whether spacing difference between semicolon and double ampersand is that double ampersand only works if the previous one succeeded. So you understand. So if the previous one didn't succeed, it will automatically crash. Now let's talk about file permission. If you have a file in your system, does it mean that everyone have rights to open the file, to read the file, to write the file, to delete the file, execute the file, and all that? So that is very, very important in file system, because when you grant people access to your computer through network or whatever, do they have all the permissions you have? Do they have all the are they able to execute all the commands that you, the owner, can execute? So this is controlled by this permify permission. So R for read, W for write, X for execute. Do you understand? So then it's grouped into three for the user, for a group, and for others. So people that are into networking, you understand this better. So depending. So it's also very important because most files that are executables like Bash, Python, you must give them the executable permission for them to be able to execute. That's very important. So if you want to see the permissions of a file, you can use ls-l to list the file and see what are their permissions and all that. You can also use chmod, change the mode, the permission mode of a file. You can use +x, +w minus x, just whatever permission you want to add or remove. You can use plus or minus to do that. So only users can change file permission. So that's very important. Now, wildcards are something that, if you are working on the command line, is something that is very beautiful. Your ability to select all the files that fit a particular pattern. That is very important because that is what helps to run loops. That is what helps. It is very, very fast to access file. Do you understand? So if all my files ends in .tx, I can select all the files that end in .tx by using an asterisk sign. It means, oh, find me everything. That is a wildcard. Now there are many other wildcards that can be used. As you can see here, question mark matches any single one character. So it doesn't have to be a particular file extension. If there's just one particular character, it doesn't matter whether it's an A or I or full stop, it will match it and then bring out all the files that follow that particular pattern. And then so many of them, sorry about that. So many of them that are available for you to use. Then you can also see here wildcard and their meaning. So you can try them out and see what it gives you. Okay. Now, let's talk about accessing a remote server. So what if you're working on your laptop and I have my own laptop? I've created a server and I want you to have access to it. Or you're working on your own laptop and there's a remote server out there. There's a supercomputing cluster out there you need to hook up to run your molecular dynamics, to train your machine learning models or whatever. So what do? SSH is the secure shell server that helps you access files remotely. So it works by encryption. So it generates a key that is encrypted over the server and decrypted at the other end that gives you access to that end. So that is what you call public key exchange. These things are like crypto exchange. So these things are hashed, automated, they're encrypted. You understand? So they are based on trust. They are like a handshake between two people where they exchange information. Do you understand? Without allowing it to leak over the network, because leaking means people can hack into it, right? Okay. So there are many ways you can easily access other people's servers. You can use window-based app like FileZilla, very useful. You can use Bitwise. I think I use Bitwise. It's actually very nice. No, but there are still other ways to do it on the command line. We're going to come to that in the next slide, right? Okay. So now this enables secure system administration. So it means that I can create a joint system and then allow everybody, all the users, to have access to it using SSH, right? So all these things are available. It's important to connect to high computing clusters, HPCs, for your simulation or drug design project, whatever you're running on. Okay, now on the terminal, you can actually call SSH and then the SSH link that is connecting to the terminal, you put it, it will bring you to the terminal. Then if the terminal is secured, they might ask for a password or a key, whatever, for you to log in. Now, the same thing. So if they're asking for a key, use a key. If they're asking for a password, so some of these things are set up prior. So if you're logging the first time, they will ask for a password, but you can encrypt the password, add the password to your private key, so that successive attempts, you don't need to put your password in again till you get that. Okay. Now, if there are files in the server and you want to bring them to your local laptop, or maybe there are files in your local working space that you want to take to the server, how do you do it? So scp is one of the important commands. So for example here, scp, I'm copying a file named boot.sh into an online server, jolo at foo.edu, and then into a folder called project. I'll run this. If I already have access, it will copy automatically. If I don't have access, it will request for key or password. So basically that. Now, the same way, if I want to copy from there, for example, I want to copy output.txt file from jolo at foo.edu into my current directory. Remember, we'll talk about full stop current directory. So I'll run it, it will work. So in the place of scp, you can also use rsync. Rsync is also a very useful tool. You can run it verbose, many things. There are many functionality in rsync, and it is very useful. So that's that. Now, I've explained, this is just an introductory class on Linux. My goal is not to make it exhaustive. It's just to tickle your inquiry, because if you are going to work on drug discovery projects, believe me, you need to know about Linux. You need to be able to script on the command line. All the computing clusters available today uses Linux, or the supercomputing cluster. So you must be conversant with Linux. It's something you keep learning every day, how to work around it, right? Okay, now let's talk about some important things. Now, there's no difference between names of files and names of directory. So you can call a directory Shadrach. You can call a file the same name Shadrach. It won't shout because it can differentiate a file from a directory, right? So directory here will mean a folder. Okay. Now, no two files can have the same names. Do you understand? So, if two files have the same names, then they must have different extensions. You know what to mean by extension? .pdb, .sdf, .docx, .csv. They must have different extensions, but something must differentiate it to files. Now, files in different directories can have the same name. Yes, so you can actually have two files with the same name, but they must be in different directories. Now, because they're in different directories, they're already separated. Their paths are different, so there's no conflict. Now, Linux is case sensitive. So course data, all the course data, three of them here are very different. So random combination of the same words by changing the capital letter, small letter means different. So you have to be careful about it. Okay, so let's talk about, I think everything is there. So the extra resources, these are just some of the basic things you can learn more about Python from Ubuntu itself. The most importantly, this resource from Cornell University is very good to understand HPC and how to work around it. All right. Thank you so much for listening to me.